Okay, so notice the title of this section is Special Products. So product, we're still multiplying polynomials, but particular binomials. Okay, so remember we ended the last one by saying we got to be careful. We had a 3, but we got to be careful and recognize that that square doesn't distribute over a plus. This is not x squared plus 4 squared, right? Not with a plus. Ooh, be careful. It means you've got to multiply x plus 4 times itself twice, which now means x times x is x squared, x times 4 plus 4x, 4 times x plus 4x, and 4 times 4 plus 16. Like terms, x squared plus 8x plus 16. Okay, so not x squared plus 16, right? We've got this middle term. But if I have something all squared, look what happens. It is the first one squared and the last one squared. And in the middle, it's just, I've got 2 of these. I've got a 4x and a 4x, right? If I multiply those together, hey, that's a shortcut. I can start going immediately from this to this, which is going to be really beneficial. Now, when I'm just multiplying polynomials, I don't have to memorize this. But if I do, it's going to help me tremendously later. It's going to help me with factoring. And more importantly, when we get to college algebra, we do a whole lot of this. And we're going to have problems that take a whole page. And if I can cut out steps, it's going to be nice. Okay, so that's what we're going to practice this time. Okay, one of our special products is called a perfect square trinomial. It's a trinomial, when you get finished, that you can write as something that's all squared. So a perfect square trinomial we get a shortcut for, and then in a minute we'll see another kind we get a shortcut for. But first of all, perfect square trinomials. So how can I multiply these out in one step? Okay. I square the first term, and I square the last one. Now, to get the middle, I multiply everything together. So 2x times 1 is 2x, and double it, right? So 2x and 2x is 4x. This sign will always be plus because it's something squared. Even if it was a -1 here, -1 times -1 is squared. And this sign will match whatever sign is in the middle. And look, I multiplied that out in one step. I didn't have to write it twice and then do my distributing. One step. So this one is, you square the first one, so 5r times 5r, 25r squared. You square the last one, so think about this, negative times negative. It's always going to be positive 36s squared. And to figure out what goes in the middle, you multiply these two together. So you get negative 30 rs and double it. Negative 30 and negative 30 is negative 60 rs. Okay. So now on the next ones, I'm going to start going one term to the next. Right? So you can do it either way you want. Do your 2 squares, figure out what's in the middle, or go across if you have trouble kind of spreading it out in the appropriate amount of space. Let's see how that will work. Okay. Oh, and look at this, even with a fraction. Oh, it's going to make it so much nicer. Because I'm going to square the first one. Now, I'm going to multiply everything together. Square the first one, multiply everything together. So that's going to give me half of 3 halves k. 3 halves, right, when you multiply half. But if I double that, oh, that's really 3k. And it's going to be a minus. And then square the last one, right? squaring the last one means you multiply straight across. Okay, now here, I've got to do this part. I can't distribute. I cannot do that. That means I'm putting it in both binomials. This is three things multiplied together. Here's two of them and here's one. You got to do two at a time. And when it's written like this, unless you want to write it with an x, 2x plus 7, 2x plus 7, and then distribute your x and then do it, why you'd want to do that, I don't know, because we have a shortcut here. Okay, x. Now, you square the first one. You multiply everything together, so that's 14x, and double it. And then you square the last one. Okay, so it's kind of like you do this, you square it, then you do them together, and then you square it. All right, so you kind of move across the binomial. Now, I'm not done here because I have this extra O. I've got to multiply it now by x, so I've got to distribute that x through. So 4x cubed plus 28x squared plus 49x. Okay, now notice these binomials are not exactly the same. I could not write that as something all squared. So we've moved to something different. Let's multiply it out and see what happens. 3 times 3 is 9. Negative 3y plus 3y and minus y squared. Oh, look what happens on this one. The two things that's the same, so I still have the first one squared, the last one squared, but this time the two things that's the same in the middle have opposite signs, because I had opposite signs up here. So they go away, and we're left with 9 minus y squared. So these are called the difference of squares. So the two kinds of special products, if they're exactly the same, perfect square trinomial. If everything's the same but the signs in between are opposite, it's called the difference of square. Look, that's a square number, that's 3 squared, that's obviously a square, y squared, and it's a difference of squares. This also we're going to use a lot, so it's handy to know the shortcut. And what this shortcut is square the first one and last one, put a minus in it, right? I don't have that extra bit because they add to 0. All right, so let's try that. Oh, and here it kind of sums up. Okay, if you've got a perfect square trinomial, they're calling it the square of a binomial, but this is a perfect square trinomial, right? This is how they multiply out. You square the first one, you multiply them together and double it, square the last one. Okay, this will always be a plus. This will match that sign. The difference of squares, you square the first one, you square the last one, and it's got a minus in between. All right, so let's try it. Hey, this is the difference of squares. Everything's the same, but there's a plus and a minus. So you square the first one, you square the last one, and there's a minus in between. Okay, same thing, because they have opposite signs. You square the first one, you square the last one, and there's a minus in between. Okay, now I can do any two of these I want at a time, but if I happen to notice, hey, I get a shortcut for these, I'm definitely going to do those. You square the first one, you square the last one, and there's a minus in between. Now, I still have to distribute that last x. And now it's all multiplied out. Okay, same thing here. I get a shortcut for those, so I'm going to multiply those together first. You square the first one, and t squared squared, right? T squared squared is t to the fourth. You square the last one, and there's a minus in between. Now, you distribute the -7. And you're done. Okay, look at this one. This is the same kind of problem we ended on the last slide, except we didn't know our shortcut yet. So I'm going to say, instead of just doing that, writing that out 3 times like we did last time, we can do it like this. Here's 1, and there's 2. And I'm going to do this part first because I have a shortcut for it. You square the first one. You multiply everything. Now they're exactly the same, right? Exactly the same. So you multiply everything together and double it. Instead of it canceling, you have 2 of them. So 4x and 4x is 8x, and then you square the last one. Now, I'm done with the shortcut. I still got a bunch of distributing here. But if you compare this slide to that last slide, we just saved a ton of work. Okay. So here we go. 64 x cubed plus 32x squared plus 4x. Now move to the next one, and it's just a 1, so 16x squared plus 8x plus 1. And let's see if we have any like terms. There's not another cube. There is another square. So 32 plus 16 is 48. And let's see, yeah, here's another linear term. 8 plus 4 is 12x, and I can see that all I have left is plus 1. Okay, let me know if you need anything. See you next time.